Okay, question 16. It says a particle of P moves along the x-axis. So let's just do a little sketch. There's the particle. There's the x-axis. At time t seconds, its acceleration is that. So double arrow. I dare say it's measured in the direction of x increasing that way. Yeah, so make sure you've got the arrow in the right direction. So read on. And we know that is 5 minus 2t, and because t is involved, we know we've got variable acceleration. Okay, so possible integration or differentiation going on here. It says when t equals 0, so at t equals 0, we know that the velocity is equal to 6 meters per second measured in the direction of x increasing. Find the time p is instantaneously at rest in the subsequent motion. So what we've got here is acceleration, and we know that acceleration is equal to dv by dt, and we know that acceleration is actually equal to 5 minus 2t. So if we want to go backwards from acceleration to velocity, we're going to need to integrate both sides with respect to t. So we're going to integrate this side, dv by dt, with respect to t, and it means we're going to integrate that with respect to t. Yeah, you could put these limits on. I won't go on to that. I'll just do it the way I've shown you. So integrate this, you end up with v is equal to, integrate this, you end up with 5t minus 2t squared over 2 gives you t squared plus the constant of integration. Now to find this constant, we've got these boundary conditions just here. So at t equals 0, v equals 6, then we've got 6 is equal to, well, that's gone, and c. So therefore our velocity equation with respect to time is going to be 5t minus t squared plus 6. Right, so we've got our all-important velocity equation now, and from that we can now go ahead and do the question. So the question says find when in a subsequent motion when p is instantaneously at rest. So in other words, we're going to say at v equals 0. So we've got 0 equals 5t minus t squared plus 6 times through by minus 1 and rearrange. T squared minus 5t minus 6 is equal to 0. Factorize or use your calculator, but this looks like it will factorize nice and easy. So we've got t 5 and 6 and 1, and that is a minus and that is a positive. So therefore the time is instantaneously at rest is t is minus 1, which is impossible. And t equals 6, and that's the one that we want. Okay, so find the time is instantaneously at rest again. Okay, so maths doesn't know that you can't go back beyond time, so that's the answer that we want. Okay, so just remember again, you've got displacement x, you've got velocity and acceleration. To go down here, you differentiate. To go backwards, remember, you integrate. Okay, and when you integrate, you're going to get constants of integration, and that applies if it's two-dimensional or one-dimensional, as this is one dimension because you're only going in the x direction, but you could move x and y and you'd have two constants from, if you remember rightly. Okay, so I hope that helps.